So we talked yesterday about absolute value equations, and today we're going to solve absolute value inequalities. So the short story is that you will have an and compound inequality. So we're going to use the compound inequalities lesson as well as the absolute value equation lesson, putting them together. An and inequality will be whenever you have a less than or equal to inequality. And the or inequalities are the opposite. They're going to be greater than or equal to inequalities. The steps are to isolate the absolute value expression, just like we did with equations. And then we have to write our two inequalities. So the first step, or to write the first inequality, you basically just rewrite the inequality and drop the absolute value bars. The second inequality that you write, you will drop the absolute value bars, you will flip the inequality symbol, and change the sign of the number. So for our equation, we would have a positive and a negative constant that the equation was equal to. We still have that. The difference is that we also have to flip the sign now. So let's look at an example of that. So here we are with our first inequality. And remember, we have to isolate the absolute value first. So I'm going to add the 1. Oops. 9 plus 1 is 10. And then remember, this is not distributive property we're going to use here, so I'm going to divide both sides by 2. So I have the absolute value of x minus 3 is less than or equal to 10 divided by 2 is 5. So there's my isolated absolute value expression. So the first thing I'm going to do is, because again, the absolute value is going to be 5 or negative 5, or the stuff inside. And it's going to, the first one, I'm just going to rewrite without the absolute value bars. The second one, I'm going to rewrite, but I have to flip the symbol to greater than or equal to. So this is the new part. Everything else is the same. So I'll solve this. I got x is less than or equal to 5 plus 3 is 8. And I'll solve this one. So x is greater than or equal to negative 2. And so again, this is a less than or equal to inequality. So this is an and compound inequality. And you can tell when you start graphing most of the time, except for special cases. So I'm going to put a 0 here. I have a negative 2 here, and 4, 5, 6, 7, and 8 here. This says x is less than or equal to 8. Less than or equal to is going to have a closed circle going this way. This one says x is greater than or equal to negative 2. That's also a closed circle going this way. So this looks like the typical and inequality graph. And the way we could write our answer in inequality or set notation would be this. All right, if we look at the next one, we can see that the absolute value is already isolated. So I'm just ready to go straight and write my two inequalities. So I'm going to keep 2x plus 1 is greater than 5. And then I'm going to write 2x plus 1. I'm going to have a negative 5, and I have to flip the symbol. So again, don't forget to flip. So you make no changes and you make all the changes. I'm going to solve this. And I'm going to divide by the 2. And then I'm going to solve this one and divide by the 2. So x is less than -3. And because this is a greater than symbol, I'm going to have an OR inequality. So here is 0, so I have -3 and 2. X is greater than 2, so that's an open circle. Greater than, the numbers greater than are this way. And less than -3 is also an open circle, and the numbers less than -3 are this way. All right, here's our third example. So I have to isolate the absolute value. Now, a common mistake here is that students will add the 1 and the 3 and get 4, but remember, you cannot add before you do multiplication in order of operations. So we can't do that yet. So I'm going to subtract the 1 over. That leaves me with 3 times this stuff, and I have 15, and I can't multiply, so I'm going to divide both sides by 3. So I got the absolute value of x minus 1 is greater than or equal to 5. So I rewrite the inequality without the absolute value bars, and then I rewrite the inequality, but I flip the symbol and make the 5 negative. So after I add the 1, I get x is greater than or equal to 6. And after I add the 1 over here, I get x is less than or equal to -4. And because it's greater than or equal to, I know this is an OR inequality. So 1, 2, 3, -4. 1, 2, 3, 4, 5, 6. X is greater than or equal to 6 is a closed circle to the right. X is less than or equal to 4 is a closed circle. Less than is that way. And our last example, we do not have to solve or rewrite, isolate the absolute value first. So I'll rewrite 3 minus 2x is less than 9. And 3 minus 2x is greater than -9. So I'll subtract the 3. That leaves me with -2x is less than 6. Divide by -2, and do not forget the important thing that happens here. 6 divided by -2 is -3, but because I divided by a negative number, I have to flip the symbol, and it's now greater than. Over here, subtract the 3. So I have -2x is greater than -12. I'll divide by -2 again. So I have x, and this will give me a +6. But again, because I divided by a negative, this flips, and I have x is less than 6. So to graph, it's less than, which tells me it's going to be an and inequality. 1, 2, 3, 4, 5, 6, and -1, 2, -3. So x is greater than -3 is an open circle that way. X is less than 6 is an open circle that way. And now you know how to graph a compound inequality. An absolute value inequality, both.